right, and we are back. So today we are talking about arithmetic sequences and partial sums. So you've already seen some summations, but arithmetic sequences, very similar to the word arithmetic, because literally it has what's called a common difference between terms. So a common difference means you add or subtract to get to the next term. So basically it turns out to be a linear function if it's arithmetic. So this is just a little heads up about how it works. What you'll see is that this is your common difference. So common difference, you can literally take A2, your second term, and subtract A1. That's always how you can find your difference, which is D. Or you could literally just see, like, what are you adding? It's 4, so that's D. The rest of the sequence we get from something else, so I'll go through how to get that in a second. But even for this one, what you'll notice is that we are literally subtracting 5 every time, so that's your difference. Notice that that's the thing that's next to n. Okay, the 7 we'll figure out how to find in a second. When you find the nth term, or sometimes they call it the explicit formula, it's another name for nth term. What you do is, they kind of write it backwards, but this is your difference. N is any term, so any term number. So say you're given your first term, that would turn into a 1, okay? This is literally A1, which is your first term. So say your first term is 2, that's what you'd plug in for A1, okay? And then AN just means any term. So any term number versus any term is a little different. So these are your terms. The term numbers would be 1, 2, 3, 4, and so on, okay? So once you have the formula, it's pretty easy to plug in, and you guys won't have to memorize it because we're distance learning, which is convenient. So they want you to find the nth term for an arithmetic sequence. They have to tell you that at the beginning, because otherwise you can't assume it, whose common difference is 3. So that means D is 3. And whose first term is 2. So that means A1 equals 2. So if I use my formula, this is pretty nice because they give us all we need. I can plug in, oops, sorry, I went to the next page. N stays N because we want to find an equation that works for any term. And then D is 3. And then all you have to do is simplify that. So it becomes AN equals 2 plus distribute the 3. So AN equals 3N minus 1. So that is your nth term. And the nice thing is, if they now asked you for the 20th term, you could plug in 20 for n, and you could find the 20th term very quickly. All right, let's try it again. I'm going to have you try the next one. They gave you the common difference. They gave you the first term. Plug it in, simplify, hopefully get what I get. Alrighty, if you got a sub n equals 5n minus 6, you are correct. Nice work. So if you didn't get that, just be careful that there is subtraction here, technically, once you distribute that. All right, we're going to move on so that these notes do not take forever. 1 is 2. Okay, so now it gets a little bit more complicated when they're talking about something that involves something besides the first term. So we're going to get into that in a second. I just want to zoom in for you. Okay, so what I like to do is just write out what they give me first. So they said the fourth term of the sequence, so a sub 4 equals 20. They also said the 13th term is 65. They also said write the first 13 terms of the sequence. No, let's do the first 5. That'll be easier. I don't want you to have to be here all day, so. All right, so if your fourth term is 20 and your 13th term is 65, some of you can probably figure this out in your head, which is great, but just for ease of what's coming up later, I'm going to use a formula. So I'm going to use my a sub n equals a1 plus n minus 1 times d. Now what you might notice is that this number matches this number. This matches that for a reason, because you can actually change those out. So let's say instead I'm given a13 instead of an. I can use that to find the difference. So I can say a13 equals, I'm not given a1, so I have to sub that with a4 because that's actually what I'm given. I tend to put the smaller number in for the a1 and the larger for an. But then we still have plus. This time I needed to replace n. So notice in the original equation, I changed n to 13. So that means I need to change this n to 13. I also changed the 1 to a 4. So I need to change this one to a 4. And this way I can find d. And then your last step is to just plug in what those terms are. So like a sub 13 is 65, because they gave it to us. A sub 4 is 20. And then 13 minus 4 is 9. I end up with 45 equals 9 times d. So I get d equals 5. So then from there, you can either go backwards. Sometimes it's easier just to think about if the fourth term is 20. 1, 2, 3, 4. You know your fourth term is 20. You can literally just go backwards. Like, you know the next term is going to be 25 because the difference is 5. But you can also subtract the 5 and make this 15, 10, and 5. So your first 5 terms would be 5, 10, 15, 20, 25. Or if you're a person who likes to use formulas, now you have your difference, and then you could solve for your first term if you wanted to. So you could just like plug this all back in and say, now I'm looking for my first term. I still only know my fourth term. So I could do like 1 minus 4 times, now I know d. So then I could do a1 equals a4, which is 20, plus negative 3 times 15, or times 5, which is negative 15, so that gives you 5 for your first term. And then you can just use your difference to keep going. So it's up to you. I tend to find this a little easier because you can just like list it out and go backwards. The tough part is if they give you like the 20th term and they want like the first 5, because then it's tough to go backwards. But you can always use this formula and substitute what you need and get what you can solve for. So the next one, they want you to find the first 9 terms of an arithmetic sequence whose first term is 2 and 9. The first 2 terms are 2 and 9. This time they want you to use a recursive formula. So this is actually a little easier. A recursive formula is different from your nth term because you're saying, like, what are you doing to the next term to get to the previous term to get to the next term. So if your first term is 2 and your second term is 9, and we know this is arithmetic, you're adding to get your next term. So you can actually set up an equation. This is only for recursive formulas, where you could say a sub n equals, if you forgot what the notation one, it's a sub n minus 1 from the previous notes, plus 7, because this is saying take your previous term, add 7. So to find the 9th term, what you could do is literally just say, I can keep adding until I get to my 9th term. Okay? So you could like just keep adding until you get over there. So they're saying just keep adding 7 until you get to 9. So it would be 2, 9, 16, 23, 30, 37. We have 1, 2, 3, 4, 5, 6, 7. So that'd be 44. 8 would be 51, and 9 would be 58. So you could use that instead. Now, again, you could always use, if they didn't ask you for a recursive formula, they could always ask you for an explicit way to do it, and then you could just come up with the formula, like from up there, plug in 9 to find your 9th term, and you would be done. Now, one quick note about For example 3, if they ever asked you for the explicit formula for this, what's nice is you can plug in any term for A1 instead. You just need to make sure that you simplify at the end. So that's a big thing about these. All right. So it says find the 10th term of an arithmetic sequence that begins with 7 and 15. You can use either method. I'm actually going to show both ways. So you can either use a recursive formula or you can use an explicit, which was that top question. So whichever method you prefer, pause the video, try it out, and I'll have the answers for you when you're done. All right, so I did it both ways. The recursive way, you have to find the difference between the terms. So in this case, it's plus 8. So your recursive formula would be a sub n minus 1 plus 8, and then you could just literally say you're adding 8 to get all the way up to here. Now, the problem with that is it's a little tedious. I actually find the explicit formula a little faster because what you can do is just plug in, you're finding a sub 10, you know a1, so you can plug in 10 for n. Your difference is 8, you can figure that out quickly, and then all you have to do is subtract, multiply, and then combine like terms, and you get 79 a little bit faster. So either method actually works for this unless they specify they want it recursive or explicit. Explicit, just remember, is the same thing as the nth term. All right, moving on to sums of a finite arithmetic sequence. Finite means it ends, which is really nice. So I have an infinite. So this is actually a shortcut. What's crazy is that if you know who Gauss is, he was a mathematician. He came up with this formula when he was like 8. He was annoying his teacher, so his teacher was like, all right, go add up the numbers 1 to 200. And he did it in like 30 seconds because he found a pattern. You know, back in the day when they had nothing else to do without technology. So what this is it's a sum instead of numbers. Same idea, this is your first term. This is usually your last term or whatever term they give you. This is your number of terms. Okay, and when you see it in play, it'll come out a little bit easier for you. But what you should notice, first of all, is that you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms that you are going to add together. Now, what you probably want to do is figure out what your first term is, how many terms you have, what your last term is, and then you just plug them in. So say I wanted to find the sum of all 10 of these terms, all I have to do is plug in the information I'm given. So I have 10 terms divided by 2. A1 is 1, because that's my first term. AN is 19, because that's my last term. And then I just combine like terms. So I get 5 times 20, which is 100. So if you wanted to play with what his teacher told him to do, he noticed that there was a pattern, and it happened to be this formula. So it's pretty cool. As an 8-year-old, I did not have those ideas in my head. For sure, I was still playing with Barbies. Anyway, so find the 150th partial sum. What that means is they want to find 150 terms. Now, the only problem with this is that they don't give you that last term. They don't give you a sub n, or in this case, a sub 150, okay? So this is where you have to use both formulas. You have to use the sequence formula and the sum formula. So let's start with the sequence formula. That's your a sub n equals a1 plus n minus 1 times d, okay? You want the 150th term because we don't know what that is. The nice thing about the previous one is they actually gave it to us. So we want to actually solve for it. So I have a1. In this case, n is 150. And my difference, I can just look up here. I'm adding 11 every time. So that is d. Okay. If you were subtracting 11, it would be negative. So I have a150 equals a sub 1, which is 5. 149 times 11. And then you can plug that whole thing into your calculator if you want to. But your 50th term is going to be 1,644. Okay, so what you can do from there is now plug that into your sum formula. So we have S sub 150 because we want 150 terms added together. N is 150 over 2. Now A1 is 5, we already knew that, but our last term we just found. So now I can find the sum of all of these. You can plug it into your calculator, but you end up with 123,675. Woo! Crazy. Oh, I just want to see if there's anything else. I don't think so. Okay, we're good. All right. Last one. This is an application. I mean, you guys can see a lot of applications in this, hopefully, that you can just like add things together quickly. It's like a lot faster than putting it all in your calculator at once. But what they're saying in this problem is that a small business sells $20,000 worth of sports memorabilia. Then they sell $15,000 each year after that for 19 years. Assuming that this goal is met, find the total sales during the first 20 years this business is in operation. So what I want to remind you of is a few key pieces of info. A1 is 20,000, okay? They're saying that the owner of the business has a goal of increasing sales by 15,000 each year for 19 years. So that means for 19 years after, which means it's going to give you your 20 years. So that is D. They want to increase by 15,000. Now, it says find the total sales during the first 20 years they are open. So because they're saying total, they actually want the sum. So give yourself a little bit of space because I'm going to put this at the bottom because we want the sum of the first 20 years. Okay? We have a lot of information. The nice thing about these formulas is you're going to be able to plug in and then be like, oh, I need more information. So you know you're trying to do 20 years over 2. Your first year was 20,000. We know that. But I don't know how much we made in year 20. That's the key. So I need to use my A sub n formula. See if you can plug that in. Actually, we would really want A20, right? What I want you to do is try to get your 20th term, plug it in here, and then you'll see the answer. So pause the video, try to finish out this entire problem now that we've set it up together, and you should have what I have. All right, so if you are familiar with business at all, this is pretty good for 20 years. You probably have to pay off, taxes and rent and all that stuff for a small business, but that's pretty good if that was his total operational product, basically. If you had trouble finding the 20th term, feel free to look at my work up here, and then you just plug in the last term, which is the 20th term, to the sum formula, and you get over $3 million, 3.25, which is great. All right, folks, we are going to do a little more practice just as a heads up about what's coming up this week. I'm going to give you very little homework on this tonight. On Monday, we're going to do a little quizzes for 8.2 practice. Then we're learning about geometric sequences on Tuesday, which are like you multiply or divide to get to the next term. We'll practice Wednesday, and then Thursday is going to be a little mini assessment of what we've done so far. Okay, so if you have questions, stop into my office hours, and I hope you have a wonderful rest of your day.